Anyways, our next speaker is Andy Geddes from Scottish Power. Andy has 30 plus years in the power industry, inclusive of roles in nuclear, fossil, and hydro. Andy has been instrumental in developing systems and practices for maximizing benefits from control systems at Scottish Power. He's going to discuss the importance of integrating safety and asset management to achieve safety, reliability, and profitability. And he's going to explain how Scottish Power has developed a holistic approach to process safety, which involves integrating a number of initiatives into a program of activities around hazards, alarms, and risk management. Please join me in welcoming Andy Geddes to speak.
Come on, baby, baby, take my hand. We'll be able to fly. Baby, I'm your man.
Small team, about 5 people. We're really responsible for governance within the business, and that covers interpreting legislation and turning into new practice guides, giving help to the sites and how to actually implement that. Do you want me to do something with this? Yeah. It's on. Okay. And so a lot of our time is actually trying to help the sites achieve compliance, but in a practical way rather than a box-ticking exercise. Scottish Power itself is actually owned by a company called Iberdrola, who are quite a global company. They operate in the US, Brazil, Mexico. In the UK, they trade under the name of Scottish Power, and we're referred to as a vertically integrated business. In other words, we generate and distribute all the power throughout the business as well. So we have 3 main businesses: the energy networks, which is all the distribution system from power coming out the power station right down to the customer's meters. And we have a renewables business, which is probably Europe's biggest renewables generator. And then the bit I work for, which is the thermal generation part of the business. And we've seen quite a lot of changes through the years. We started off mainly being a base load type operator, and increasingly as wind power and the energy markets have changed, we've seen a drive towards having to respond, and plants that were designed to switch on and run for a year or so at a time are now coming on and off maybe sometimes twice a day. We're also geographically spread out, so we have, let's see if we have this, we have hydro, we have gas storage, we have pump storage, we even take about 50% of the sewage from Scotland and convert it into fuel pellets and sell it on to other people. And of course we have traditional more CCGT plant in Garnet, which is still, although it's 40 years old, is still the 3rd biggest coal plant in Europe. So quite a variety of plant. It's a lot of different ages, a lot of different technologies, and because we're always upgrading somewhere, we never actually have a consistent plant base. So it's one of our challenges is how do we operate and manage all this equipment from different suppliers. And it's actually one of the reasons why we chose PAS, because of their ability to actually be system independent. So really what I was wanting to cover is maximising the benefits from the control systems, because basically I'm a control systems guy. But A lot of the time we have to do that through change management and people and stakeholders, so I want to talk a little bit about that. And also to look at how we made it sustainable and drove the thing, because quite often it's easy to do a project and get it installed, and a year later you're lucky if 40% of what you did is still going on because everybody's moved on to the next project. So there's quite a lot of effort that we've put into making things sustainable and keeping the benefits once we've got them. And there's a lot of focus around about risk management. I think a few people have said this morning about how essentially operators are people that manage risks. Well, we're no different from anyone else. So risk management plays a big part in what we've done. Okay, so control systems. About 10 years ago, we started a project called Operational Excellence. And we had some main goals. So there was obviously a focus on safety, where we didn't want to do any harm, but also nothing happens if you don't make a profit. So there was also a focus on efficiency, performance, making that it's sustainable. We realised that we had to do quite a lot of work round about people, because without people, I don't know if the laser goes that far, yeah. Without people, a lot of these programs just fail and die, and there's a lot of environmental legislation, so we had a goal there as well to achieve things with the environment. But what I've found is that the control systems are almost invisible to a lot of the senior executives in the company. You know, most of it is sat in cupboards at the back, locked away, and for good reasons, for cyber security and everything else. But it's probably one of the least recognised assets that a power company has. It's easy to walk down the turbine hall and see a boiler and a steam turbine, but the control system's hidden from view. But without it, a lot of what you're trying to achieve is really quite impossible. So without the control loops, the main function of this thing is to keep your plant running at its optimum level, so it ties in very nicely with the efficiency and keeping the plant running at the right points. Also ties in nicely with reliability. You're not wearing the plant out, you're not doing damage to things or aging the plant unnecessarily. But interestingly, if you're operating the plant well, the control systems can start to become almost some form of condition monitoring, because most systems now are digital. We tend not to have much of a drift in the control system, so usually when control loops start to go wrong, 99% of the time it's because it's a valve or a pump or something out in the plant. So starting to pay attention to how your control systems work also feeds into targeting where you might need maintenance in your plant. It becomes almost an early warning system as the performance starts to trail off. But of course, it's also one of the first layers of protection and being safe if your plant's working at its optimum values. So that was a big focus for us. The next level is the HMIs, because obviously that's where you hope the operators will start to pick things going wrong and do things, and hopefully it's also a trigger for the operators to contact the maintenance teams and actually get them to go out and do things. So again, that to me is quite an important thing to have there and make use of. And we've certainly been looking at the HMI type advice from PAS, and we've done a few bits of work there. Our plan is really to do more of that as systems need to be upgraded. It's too big a project to actually just do for the sake of doing it itself, but where we have done it, we've seen quite a good response from the operators. And then the alarm systems, which is how we came into contact with PAS in the first place, trying to improve them. particularly on the big site, along Garnet. It was built 40 years ago. When we look back and we looked at the original design, there was about 350 alarms for each operating unit. And when we went into the control system, we found there was something round about 4,500 alarms configured on the same unit. And it did raise a question of how did we end up with so many alarms? How did they manage to run that plant quite well 40 years ago without them all? And that's where we started to realise that we needed to do something about alarms. And we started doing it from the point of view of improving the loading on the operators, and for all those good reasons that AMUR and ISA standards talk about. But we've now got to the point where we've got the alarms under control. And what we're finding now is most alarms are for genuine reasons. And the alarm system is now more becoming something that focuses maintenance activities. Because, again, like the control loops, most of the time when you get an alarm, it's because there's something wrong with a physical asset out on the plant. And this is really a theme that's built up with us, is that although we start doing things from the point of view of safety, quite often it's very closely connected to the way we manage our assets anyway. So it's quite useful. So that's alarm management. And I think, and now where we're starting to do, and we're just about to go live on a project, is look at the process boundary type work and start feeding that in from the control systems. And again, the control system's really a huge resource. It's not just about the controls for us, it's about telling us the condition of the plant. It gives us a massive amount of information out to the management and making decisions about what's going on. And I think I've been around lots of plants in different companies, and it's a hugely underused resource. Quite often I find people have lots of information, and they've gathered it, and they spend lots of money on putting it in historians and everything else, and then you find nobody's actually using it. So I think, to me, control systems is a much underused resource in terms of how you manage your assets and know what's happening in your plant. But that's all fine and well. The guys at the top, they have to keep an eye on making profit, and like everybody else, people like me, we have to actually persuade them that there's a good financial reason for doing things as well. Now, we had quite a few process-related incidents that really started to change the interest. Up till then, I think a lot of the interest in health and safety was very much focused on the slips, trips and falls and that kind of thing. But once we got these incidents, it really was great. It was a fantastic hook to hang a lot of our improvement projects on. This one up here, very personal to me. This is Garnet Power Station. What you can see there is the remains of the conveyor belt that takes the coal into the plant. So that's the third largest coal station in Europe, completely taken offline because the conveyor belt failed and collapsed. It's personal because when I go to that site, the office that's sitting underneath the conveyor belt is where I sit. So I was quite pleased that this happened on a Sunday rather than on a Monday morning. We also were very lucky because when it happened, no one was in the building and no one actually got hurt. But it was the incident that really started Scottish Power taking process safety a lot more seriously. But there are others. This is Bunsfield down in England. It's a petrol storage site. The whole thing started because someone didn't return a safety trip on a high level on one of the tanks. They managed to pump about 300 tons of petrol, more than the tank could hold. vapour cloud took off, and the result was the biggest fire in Europe since the end of the Second World War. So pretty serious stuff. A lot of concern about the groundwater around the area as well, because of the amount of foam and chemicals that had to be used to control it. So a pretty serious event that stirred a lot of the regulators in the UK. You guys, pretty close to home, you have your own Texas city. Again, that was quite a driver for a lot of people looking at what was learnt. And this one down here, it's not one of ours, but the main pipeline from the boiler to the steam turbine blew. The whole plant was full of steam in about 60 seconds. One guy survived. It took him months to get out of hospital. The other one didn't. The only difference was he decided to run in the opposite direction from the guy that died. So pretty serious stuff. But what that kicked off in the UK was a big programme, because we then realised there was actually a manufacturing fault on a lot of old power stations, and it kicked off about a 2-year programme of NDT testing on probably half of the UK fleet. And that kicked off a whole programme where the 6 main generators in the UK formed a body called the Generator Safety Integrity Programme. And that was at the request of our health and safety regulator, and we're now actively producing good practice guides to look at how we manage all the hazards from the coal plants in a better way. So it's been instrumental in driving a lot of good practice over the last 10 years in the UK. Of course, we have quite a lot of guidance. I don't know if anybody's familiar with PAS. PAS is not PAS as in today, but publicly available standard. It's now been turned into an official standard, and it's all about asset management. It's one of the things that we adopted early on. In fact, Scottish Power was the second utility in the world to be accredited with it. We were just slightly beaten by a company out in Hong Kong. But that drove quite a lot of our integrating how we manage assets. You can also see plant aging. That was pretty much driven by the regulators' awareness from that incident in the plant where we had the steam pipe failure, and the recognising that the fleet and the plant was designed for base loads. We're now operating at 2 shifts, going up and down load a couple of times a day, starting and stopping. And so there was a concern in the UK about accelerated plant aging. When we talk about plant aging, it's really about not the linear age of the plant, but the fact of how much of the plant's life we're using up. So if you're running the plant harder, higher temperatures, then you're eating into the useful life of that plant. So there's a lot of this RR509 coming out. Again, GenSIP with its good practice guides are there. And so the combination of these high-profile incidents and a lot of this guidance coming out off the back of it really drove us from an operational excellence programme to being a process safety-focused programme as a company. And this really just tries to illustrate how they join up. Because a lot of people, we started off, we're at the slip, trips and falls, relatively frequent but minor types of injuries and consequences. And at the other extreme, we have the thankfully very rare incidents, but when they happen, they cost a lot of money and harm a lot of people. And this is where we were worried about the plant aging and the way that the UK fleet was being used, because what we were finding was that this curve was starting to turn up or bend upwards because of the way we were using the plant. and we couldn't really just maintain it and use it in the same way as before, and we had to think about how we cope with that. And of course, there was always these common things. So there's the common themes. Leadership, behaviours is a big thing for us. Behaviours in terms of the slips, trips and falls. We actually adopted a process that DuPont developed, but also behaviours and making operators much more aware of what they're actually doing to the plant when they're asked to squeeze that few extra megawatts out of the plant as well. And yesterday I had a conversation with a couple of people, and we're all talking about the age profile and the fact that people are disappearing out of the industry in the next 5 to 10 years. We're also under pressure to run the plants with less people, rely a lot more on subcontractors rather than our own people. And so, for us, training and competence is quite a big issue as well. And what we've tried to do is these leading and lagging indicators. There's a UK regulator. They have a freely available guide called HSG 254, and that really explains the ideas of developing leading and lagging indicators in terms of your plant safety. And we adopted that, and that's been quite key because that highlighted where we had problems. It's addressed one of the issues that you had with Texas City, where the management was focusing on the slip, trips and falls, but weren't really aware of what state their plant was in terms of its safety and things. And so that's really been quite key as a driver. And the fact that we've got that in place has really justified a lot of other projects and initiatives to improve things. Because what you've got to remember is we've been doing this for nearly 10 years now. So it's an ongoing process. So really the point of this was really just to show that, asset management, process safety, behavioural safety, they're all really interlinked. We can't really put them into silos because they all affect one another. And in a previous life, I used to do Six Sigma, so I like continuous improvement, try to get rid of all that variability. And so all I'm trying to point out here is that these things are interlinked and you have to keep going round the circle. So if you start from the point of view of process safety, you're wanting your plant to work well. To be safe, it has to be reliable. To be safe, it has to be working in its optimum areas. But that's very closely related to managing your assets and preventing the plant from aging. And in terms of asset management, then, well, what's your maintenance strategy? Do you fix on failure, or do you try and do preventative maintenance, or do you, where we've been trying to go for a number of years, is do predictive type maintenance? So we use a lot of ideas from reliability centre maintenance, identifying where performance is starting to fall off, using that as an indicator that if we don't do anything in 2 weeks' time or whatever, we'll actually get to the point where the equipment's failed in terms of its performance, or maybe completely failed as in it's broke. So that's driven a whole project round about our maintenance strategy, and that's tied back in very closely to our engineering standards. And so we started at the top by saying this is what the regulator wants, this is what our internal standards are, this is what our maintenance strategy is for our plant and how we're going to achieve it. But in the main, it has to be a mixture of reactive, preventative, and proactive maintenance. And that really depends on understanding your plant and doing a lot of work around about asset criticality and knowing which bits of the plant are really, really important, which bits you can allow to fail. Because we've got to live in the real world, we've got to manage all this with the people we've got. And that's one thing we should make clear, that we've done all this work, but we've not been allowed to increase the workforce to do it. We've had to be smart about what we do and how we make use of the resources in the plant. And so, this obviously feeds onto reliability, and reliability means you have a well-performing, profitable plant. And if we don't be profitable, we won't do all the safety and everything else, because if we're not profitable, we just won't be existing at all. And that comes back round to how people behave and their attitudes again. And really what we're trying to do is keep those hazards inside the process. We can't make a plant that's completely benign. We're dealing with steam that's 600 odd degrees centigrade. You're talking about 40 bar pressure on some of these plants. So we can't completely eliminate every hazard and still make electricity. So we do have to think about how we keep those hazards inside the process. But in doing so, we achieve that optimum operation, we achieve the reliability, and most of the time that helps the bottom line and make a bit of profit as well. I mentioned KPIs and what its role in driving what we achieve. But when you come to do it, it's actually a lot more difficult in actually deciding, because it's a bit like alarm management. You don't want thousands of KPIs, or they're no use. They're just flashing all over the place. So you really have to be quite careful about what you pick. And this is all back to this old principle: if you don't measure something, you probably can't manage it. So we spent quite a lot of time, but these were the sort of key areas that we developed KPIs for. So things like competency management system, we put a system in. We put another system in that did incident reporting and management of change. We also implement, in fact, all three of them are on the same platform. The technical risk is the area I tend to spend a lot of time in, where we're looking at the hazard studies, all that type of stuff, and all the good practice and the standards. And then, of course, we've also got all the operating and engineering standards on the plant, the procedures that people actually follow in doing their day-to-day job. We also started a process of technical recommendations, so that every time something happens on a plant, we have a system where we can report it and quickly pass the findings around all the sites. And we've now got to the point where that system works globally rather than just within Scottish Power. It works everywhere in the Iberdrola fleet. Maintenance management, again I mentioned we did a lot of work on our maintenance strategy, and we did a lot of work on actually our maintenance asset records and the way we use things like Maximo and SAP and all these type of things. And these, so we're now using KPIs of planned versus actual work to see where we're keeping on top of all that maintenance. We're looking at rates between defect type cards that have been raised as opposed to routine cards, to just make sure that the routine work we're doing is actually keeping the number of unplanned defects down. And again, that affects the performance of our plant in a big way. We've put in systems for shift handover, so electronic operator logs, but again, we've tied it into the control system, so quite often these operator logs are getting populated automatically with bits of information from the control systems as well. The plant condition and limits, we started to build that into our SCADAs, but this is an area where we want to expand it further into using inbound with PAS. And of course, we do have a whole audit thing there. But the key with us was we started doing integrated audits. So rather than every week somebody came along to audit something else, we tried to minimise the impact on the sites and coordinate audits. So if we're doing engineering standards, we'll check a whole pile of other things that were related to the standards at the same time. And this is an early version of our dashboard. The whole point was that this is visible to everybody in the company that can connect to an Office PC. What it does mean is that the senior management have visibility all the time. This thing's getting updated daily, so people are aware of where hazards are. And we split it up into key areas that we were interested in. We can actually drill down in this system. So if there's one thing that's red in the bottom list, then it makes the top KPI red to flag it up, and so you can drill down into the information. So we can actually look at cards in our works management system. So this thing is very, very integrated into our works management system and information from our control systems and everything else. The whole point is we don't want armies, or we don't have armies of people to collect this information and put it into spreadsheets. We needed to automate it and make it live. And risk management plays a big part because we use PHA Pro to do our hazards and HAZOPs. That feeds in and drives a lot of our asset investment type programs. It also identifies where all the big risks are and what are the key things that we are dependent on to prevent those risks from coming out of the process. We also make a lot of use of bow ties, which are these types. I don't know if some people in the oil industry might be familiar. It's just a very good graphical way of presenting the information that are in hazard studies, so threats, controls, events. And that's been very useful and influenced the way that we structure a lot of the way the information's presented. So as the information goes further up in the organisation, it becomes more condensed, but it's speaking. A lot of the senior executives who might not be engineers or anybody else, but they can understand a picture like a bow tie fairly easily and gets the message over to them. We also, a theme that I've seen recurring is that we have, we think of things in terms of plant, process and people. And I've seen quite a few people's presentations that have got variations on those names, but it's quite comforting to know that other people are thinking the same way. And this is where we're heading. We started off when we developed the dashboard ourselves. A company called Amore then started to sell that as a product, but we had some of the rights to it, and Amore's now been taken over with Lockheed Martin. And where we're getting to now is going away from that grid type presentation and making much more use of the bow tie view of the plant, but again still using this red, green, amber traffic light system to let people know where we are. And particularly, so we're starting to focus on major accident hazards. So I've talked a lot about it, but I haven't really mentioned PASS that much. We got involved with PASS partly because I bought the book to read about alarm management, and then we asked them to come and tender when we were doing our alarm improvement projects. And so really our first involvement was really just getting those alarm counts down to the operators. We quickly realised that there's a lot of good reporting tools in there. And again, what we do is very rarely people use the reports or use the system. Most of our sites now rely on weekly reports being posted out to them, and this drives them chasing the top 10 worst alarms, the top 5 worst control loops, and soon they'll be chasing the top 10 most violated process boundaries. But again, the whole theme of this is trying not to put the onus on people filling things in and getting the systems to provide that and user people to actually fix the problems. So it's been a useful tool. We have the control loop side of it. We're just starting to put inbound in. And again, key to us as well is that PAS produces a lot of good KPIs internally. And so we've connected PAS up to our process safety dashboard. And so PAS is actually feeding in daily information into that system. But again, without the need for any human intervention, or at least on the data side. And the theme, I guess, was connecting the dots. So a lot of what we have is based on our good risk management hazard type things. That feeds into the design of our plants, that feeds into how we're managing our control systems. And of course, PAS is the main route into our KPI dashboard, and the same with the alarm systems. And the process boundary, interestingly, what we're now doing or looking with inbound is using it to monitor demand rates on safety systems. And we're starting to use it to identify maintenance boundaries. So the operator doesn't need to be aware, but it's starting to flag up to the maintenance team that pump is deteriorated, or the output, the discharge pressure from a pump has got to a point where they should do it. So we're starting to see how we can use inbound to fit into our maintenance as well as our safety systems. And I think we've done a reasonably good job. This woman here, Judith Hackett, she's the equivalent of the head of OSHA in America. OSHA and HSE are similar kind of bodies. So 2011, we got lots of awards from the ICME and from the HSE. So we must have done something right, because very rarely do you hear this woman saying anything about anybody, never mind saying that they've done a good job. So, okay, thank you very much.